Good morning or good afternoon. I'd like to make a quick recording on the single displacement or replacement lab activity, the one on the activity series that was due on December 20th. You can see it on the left side of the screen. I feel like in some cases there may have been some confusion about where to record the information in data table 1 and then how to take that information and put it into data table 2. So I wanted to make a quick recording, hopefully help you through that. Again, on the left-hand side is the lab document itself, so I'm just going to scroll down to data table 1. I already have this written in. Maybe I should take it out and do it over so that you can see it going in. Okay. And then over here on the right-hand side is the lab website. So I'm going to hit the start button and I'm going to do the magnesium metal, so the first one. So I'm going to click on at magnesium metal. And again, the instructions for the site and where to click is all on the document itself, so you could read through that if you need to. And now I have on my screen the 4 pieces of magnesium metal that are being held over top of 4 different solutions. So I have magnesium nitrate, zinc nitrate, copper 2 nitrate, and silver nitrate. I want to see what happens when I put the magnesium into those solutions. They're single replacement reactions because I'm taking a single element, magnesium, and I'm adding it to a compound. Magnesium plus magnesium nitrate, magnesium plus zinc nitrate. So a single replacement reaction. So I'm going to go ahead and stick them in. It's going to tell you when it's time to take them out. It says, okay, I could take them out. And now let's take a look. So before I even record anything, it looks like I have a reaction in all of them except the first one, which makes sense because magnesium plus magnesium is not going to create any change, right? It's the same element. So elements aren't going to react with themselves in that way. But the other 3 have a reaction there. I could see something's collected on that metal strip. And if you think about what a single replacement reaction is, on the product side, you would have produced or collected a pure metal, right? So if I'm kicking that, I started to get some music playing in my headset from a previous meeting I was in. Anyway, so when you're looking there, I'm seeing that metal is collected. I've isolated a metal as the product in my single replacement reactions, which is what should have happened. And so the question is, where do I record this in the data table? And so this first reaction here in this first solution is magnesium plus magnesium nitrate. That goes in the first box. Magnesium plus magnesium nitrate gave me no reaction. And now you want to move down, right? The magnesium column, because I'm adding magnesium to all of these solutions. So the next one is magnesium plus zinc nitrate. There was a reaction there. If we go back over to the website, I could see that darker gray-ish color that's collected on the magnesium strip that was in there. So something's happened, a reaction's happened. So I'm going to say yes, there was a reaction. And if you want to add some detail, you can. So I could say that zinc, because I know what's going to happen, what the product should be. So I know that zinc metal has collected on the strip. Right. So if you want to add some additional observation, you can, but at the very least you want to say, is there a reaction or is there no reaction? And so now I want to go again down. I'm going down the magnesium column. And so magnesium plus copper nitrate, this one here, yes, there was a reaction. Copper collected this time. Clearly that's a copper color, right? So magnesium has replaced copper or kicked out copper in this reaction, and now copper is by itself on the product side, and therefore we've isolated copper, we've collected that metal. And then finally the last one, magnesium plus silver nitrate, that goes in the bottom box there. Yes, there was a reaction. Silver this time was collected. Right? So you're going down the column. And so when you're ready to move to the next one, so when you're ready to do copper, you're going to click on copper, get them into the solution, pull them up, and then fill out the copper column. Copper plus magnesium nitrate, copper plus zinc nitrate, copper plus copper 2 nitrate, copper plus silver nitrate, right? You're going down the column and filling it in. Once you have data table 1 filled out, you should have 6 reactions that have happened. If you've done it correctly, there should be 6 boxes that say there was a reaction and the rest should say no reaction. And so you want to take those 6 reactions and write them out in data table 2. And so I'm going to do the first one. I think I have the first 2 actually already written in down there when I scroll down. But the first one where I have a reaction that has happened is right here. So I'm going to write magnesium plus zinc nitrate yields or gives me my arrow, and then I need to predict the products on the other side. And then I'm going to go to the next one. So I also have a reaction here. So magnesium plus copper 2 nitrate gives me what? I have to predict the products. So scrolling down to data table 2, I'm going to take some of this out and do it over for you so you see how it's filled in. But this first part, so what you're seeing right here is what you get from data table 1. So there was a reaction in that box where I combined magnesium plus zinc nitrate. So I wrote that down. Those are my reactants. That's what I started with. I wrote in my arrow, and now I have to predict the products. And so we talked about single replacement reactions in class. In single replacement reactions, a single element replaces or displaces the other metal in the compound. So magnesium as a single element, it's going to kick out zinc and say, zinc, move out of my way. I'm taking your place. And then zinc's going to be left alone, which is why we've collected it, why we get that dark gray color that's collected on the strip there to see the reaction. So I get zinc by itself, and now magnesium is with the nitrate, right? Magnesium has taken its place. It's replaced zinc in the compound. It also makes sense if you think about the activity series that magnesium can replace zinc, right? So if I'm going to scroll down here for a moment and come back. At the very bottom of this lab is the activity series itself, and magnesium is right here. It's kind of towards the middle-ish, right? Then we have zinc underneath. Then all the way down we have copper, and then towards the very bottom we have silver. And we said, according to the activity series, metals towards the top are more active. They're reactive. Magnesium's above those others. So it can replace everything that comes underneath it. So magnesium should have a reaction with everything that we're using in the lab because those come underneath it on the activity series. And you'll be asked those types of questions in the analysis section, but even while you're doing your data table, you can check your work, right? There should be a reaction with everything except itself because magnesium is not going to make a change with itself. So anyway, that's there. We've done it correctly. Magnesium should replace zinc in a reaction. And then the second one that's in our data table 1, where a reaction happened, was magnesium plus copper nitrate or copper 2 nitrate. And so again, those are my reactants. That's what I started with. Magnesium as a single element is going to kick out copper. And so now copper's by itself and magnesium is in the compound, right? If you don't remember charges, it's good to practice charges, and, magnesium's a +2, nitrate's a -1. Did I? Yes, correct. Magnesium or nitrate's a -1, so that's why you crisscross the charges, but the lab is still open here on the right-hand side of the screen. Notice that they give you those formulas. They give you the solution formulas. So it's always good to practice and have your polyatomic ion list and have your periodic table with the charges. But you could check your work here too, right? They have the formulas written right there for you. Those are all the formulas you're going to need in order to write the equations. Once you have the 6 equations written here in data table 2, you should also make sure they're balanced. If you do them correctly, there should be 3 that are already balanced. In this case, these are 2 of the 3 that are already balanced. And there should be 3 reactions that you have to balance. So again, 3 that should be fine and 3 that you're going to have to balance when you're filling in data table 2. And that's it. So once you're done with data table 2, I'm going to scooch this down and just open this whole thing really quickly. I'll just scroll